So lesson 6, circles and angles. We're going to look more particularly today at the angles inside of a circle. One's formed by either radius, which we call sector angles, sorry. And so the red lines are radius. The angle between them would be a sector angle. That would be this one right here. Or we can look at inscribed angles, and those are ones that are formed by chords of a circle. So we have two chords of blue ones. The angle between them would be a inscribed angle. Okay. A word you're going to come across a few times would be the word subtended. Okay, that just means across from, okay, and specifically across from an arc. Okay, so if I say we have a sector angle subtended by BC, means we're looking at the angle across from BC. Okay. There's a really handy idea that comes up lots and lots and lots between sector angles and inscribed angles. Remember, sector is the radius. That would be this angle right here. Inscribed would be the chord, so it would be this angle right here. It turns out that the angle formed by the sector angle, this one here, is twice the size of the one formed by the inscribed angle, as long as they're across from the same arc. Or vice versa, the inscribed one right here is half the size of the sector one right here. And that's the equation they're giving us beside the circle. Okay. Knowing that allows us to solve some problems with the angles inside triangles, or sorry, circles. Okay, so if I look at the first example, I want to find the value of x. I notice that my sector angle is across from this arc, and the inscribed angle is across from the same arc, which means that x has to be half the size of the sector, or half of 80. So it's x has to be 40. Okay, same idea, you try b. X is the sector angle, which means it's double the inscribed angle. Okay, x in this case would have to be 120. Remember, the sector angle is twice the size of the inscribed, or the inscribed is half the size of the sector. Okay. Take a look at C here. Look at this diagram. Okay. The 130 would be on this arc, but the x would be on that arc. They're inscribed in different arcs. The formulas only work if they're inscribed in the same arc, so we have to sort of think about this question in a different way. 130 is part of the circle. Specifically, 130 is on that side of the circle. I can figure out the other side of the circle by taking the idea of a circle adds up to 360 degrees. If I subtract the 130, I'm left with 230 degrees, which tells me that the angle on the left-hand side here is 230. Kind of handy because that is inscribed on that arc, right? That matches up with the x. Okay, 230 would be our sector angle. X would be our inscribed angle, so x would be half of 230, or 115 degrees. And using that idea, you guys can try and solve D, the idea of angles inside. Okay. 140 is on this arc, which would match with the sector angle on the same arc, right? That one there. 140 on the outside will allow me to figure what's on the inside. Sector is double. We'll call this y, if you will. So y is 2 140s, or 280 degrees. Okay. That doesn't really help me find x, because x is inscribed on this arc, which is the same thing that that sector angle goes with, right? Knowing y is 280, I can find z, if you will. It's on the other half of the circle, so 360 minus 280 gives me 80. And using that, I can find x, because x is inscribed in the same arc as z, and x will be 1/2 of the sector angle, or 1/2 of 80, which is 40.